Okay, let me go ahead and pull that PowerPoint up this morning as we get started. And everyone should be able to see my screen pretty clearly here. We'll get the actual presentation up here in a second or two. And can everyone see my screen okay this morning? It'll be the front screen. The first PowerPoint slide says HMH7 SEER heat pump overview with two pictures on that front slide. Can everybody see that slide okay?
Yeah.
Okay, that sounds really good. Well, again, fellas, good morning. We're going to be doing a HMH7 SEER horizontal heat pump overview. And as you take a look at these products, if you guys haven't used these products much, or even if you have used some, maybe you haven't used both platforms. We have two platforms. We have a 2-fan model, which is going to be the 4 and 5 ton product. And then we have a single fan platform, which is going to be the 2 and 3 ton. And so guys, please remember, these always come in whole tonnages. It's just 2, 3, 4, and 5 ton whole tonnages. Now, from a serviceability standpoint, we want everyone to remember, please, to make sure that our contractors or our customers out here have got these little service fittings. So what they are, they're a 5/16 by 1/4 inch hose fitting for your service gauges, your gauges. And so what this does, it actually adapts from the unit 5/16 female to 1/4 inch male. So be sure and have some of these. And I don't know, there's several different manufacturers that make these. You probably already have them on your truck if you're out there doing service work and so on. But if you don't have some of these, make sure and get them. I think Robin Air and Yellow Jacket are some pretty common manufacturer of these little hose adapters. And one of the things that we like to point out is, even though the HMH7 kind of looks like a mini split product, it is not a mini split product. It's just a heat pump. It's a modulating heat pump, and it's going to modulate between 35 and 100% capacity. But you guys are going to need to have these service hose adapters to get your gauges on. Another thing we like to talk about real quick is some of the minimum and maximum temperatures. We're not going to, really delve into this too deeply. This is right out of the install guide, but it's some interesting information in the fact that, we have a minimum cooling capability of 35 degrees. This is right out of the box on the thing, with a maximum of 122. And then a heating minimum of -5 degrees right out of the box, and 75 degree would be the maximum. So you guys can kind of look at this stuff in the install guide, but at the same time, it's kind of nice to know that we've got some good heating and good cooling minimums and maximums on our product. Any questions or comments so far? No. Everybody good? Okay. So the first thing I'd like to jump into, fellas, are going to be air handlers. I know air handlers are going to be a pretty big deal down in your area. And so what we're going to be doing, we're going to be discussing the low voltage wiring and the setup of the HMH7 with the JHVT, which is going to be our variable speed air handler, that V meaning variable speed, and also the JHET air handler, the E meaning our high efficiency ECM motor. Now the ECM motor is going to be just basically the what we call the standard ECM motor, which is going to be a high efficiency motor, but it is not variable speed. So to kind of put this in perspective, the variable speed will always have the control board where you're going to be setting up dip switches and so on. And the JHET air handler, you're going to have physical speed taps on that motor, just like the old X13 motor, but we don't call it X13 anymore. We refer to it as our standard ECM motor. So what we're going to do, we're going to review that heat pump selection, that AC and heat pump selection on the JHVT air handler. We're also going to talk a little bit about low voltage block wiring diagrams, and just real simplified wire for wire. We're going to be going through this wire for wire. In addition, we're going to be talking about wiring of the S1 circuit for reduced airflow on the JHET air handler, and how that relay logic works to reduce airflow when we have a reduced airflow command. And then finally, on our heat pump thermostats, we want to make sure that whatever thermostat you select, a couple of things. We want to make sure that whatever thermostat you select is going to have a BO selection for reversing valve operation, and we'll get a little bit more into that in a minute or two. And also, we're going to ask that whatever thermostat you select, please write this down or make a note of it. We want to make sure you have a hard wired common terminal all the way through, from the thermostat to the indoor unit to the outdoor unit. It's really important that you've got that common wire hooked up all the way, because it can cause some erratic codes to be thrown, if you will. If you have an aftermarket, or if you have a thermostat that's going to have, a power stealing, or if it doesn't have common going all the way through. So be sure and select a thermostat that you like, your favorite heat pump thermostat, but make sure you pull that common wire all the way through to prevent any erratic codes from occurring on the inverter board outside. Any questions or comments on those statements real quick?
No.
Okay, good, excellent. Well, fellas, let's talk a little bit about the AC and heat pump switch on the JHVT air handler. So when we set this air handler up, there's going to be some dip switches you're going to be getting into. And you'll notice that all the information that we're going to be talking about is in the install guide. So be sure and read the installation guide as far as the airflow configuration, your heating and high cool and low cool and so on. But one of the dip switches we want to highlight is going to be that AC heat pump switch. Now, this is really important because the JHVT air handler is a heat pump air handler, is a heat pump outdoor product. So we want to make sure and set the JHVT air handler up for heat pumps. So you're going to notice on the control board setting configuration, you're going to find there's an AC heat pump switch, and you want to make sure it's set to heat pump mode, because we have to tell the air handler that it's on a heat pump outside. Now, once we do that, once we select that HP dip switch on the JHVT air handler, the next thing you're going to have to remember is the fact that that heat pump AC switch configures the air handler for a heat pump. Now, when it's configured for the heat pump, any Y call will be considered a cooling call with the switch in the off position. And with the switch in the off position, a Y call will then be converted over to a heat pump call. So basically, if it's in the on position, it's going to ignore the fact that you've got a heat pump input, and a Y call will be considered a cooling call. But if you have it in the heat pump position, a Y call will be considered a normal heating call. Now, one of the things we want to keep in mind as well, if you accompany that heating call with a BO selection for reversing valve operation in the cooling mode, what's going to happen is that on a normal heat pump, when I say a normal heat pump, we're talking about a Champion heat pump that is not a HMH7. What'll happen is you'll get an O signal, a BO signal for the cooling call. But we want to remember something about the HMH7. The HMH7, we're going to energize the reversing valve in the heating mode. It's not bad, it's just different. We just need to remember that. So if the control is set up for an S1 input, if we set the control up for an S1 input, and you get a Y call with a BO signal, then the indoor unit automatically knows that S1 input is going to be an airflow reduction command, but it's also going to know, if we're set up, that we'll be set up with an HMH7. So I said all that to say this: just make sure you've got your dip switches set up properly, and that S1 input is set up properly. And I think it's on page number 13. You might want to write that down. I believe it's page number 13 on the install guide, where you go in and you set up that S1 input. So be sure and set that dip switch properly to heat pump on the JHVT. Make sure you've got it set up for your S1 input, and everything should be squared away. Any questions or comments on that little overview of the dip switch settings on the JHVT air handler?
Yeah, any questions? No.
Everybody good with that?
I got one, Joel.
Sure, come on.
Now, the air handler set up on heat pump or AC every time?
That's a good question. They typically come set up from the factory on AC, because we don't know what you're going to be putting it on. And so it's important that
just want to make sure.
Yeah, so
no matter what, they need to check it. But I'm just saying, I didn't know if it came default on heat pump or AC.
I like that way of thinking. So that's exactly correct. So either way, regardless, you want to make sure that AC heat pump switch is configured properly for the HMH7 outside, because it has to be in the heat pump mode. To your good point. Thank you for that good question. Good, excellent. Okay, so once we've got the dip switches set up, we've configured it as per, I believe it's page number 13. Let's talk about wiring this thing literally from the thermostat to the indoor unit to the outdoor unit. Now you're going to notice that BO selection is we're going to energize the reversing valve in the heating mode of operation. The heating mode of operation is a little different than our other Champion product. However, it's just different. It's not bad, it's just different. So heating mode on the HMH7 will energize the reversing valve. W2, if you have like a two-stage heat strip, you may not have it down in your area, but if you do have a two-stage heat strip, W2 will go to W2. That's your second stage auxiliary heat if you have a two-stage heat strip. W1 will be your first stage heat strip auxiliary heat, and that's going to carry all the way outside. Now, there's two functions for this. Number one, it's first stage auxiliary heat if the thermostat calls for auxiliary heat. But also during defrost, the outdoor unit's going to generate a W signal outside during defrost. And what that's going to do is going to bring the heat strip on during defrost. Because remember, team, whenever we go to defrost on our heat pump, it's going to actually be in the cooling mode of operation. So we want to make sure if it's the winter time and you go into defrost, you want to make sure you don't freeze the homeowner out during defrost. So that's why we have that W coming back in to our heat strips during defrost from the outdoor unit. Y1 from the thermostat, or if you just have a single stage thermostat, Y from the thermostat will go to Y/Y2 on the indoor unit, and that goes outside to Y. That's basically your compressor call. But you're going to notice something here, that Y/Y2 on the air handler, what we're telling you is that Y from the thermostat, or Y1 from the thermostat, is actually going to be commanding high-speed airflow as the default when we energize the outdoor unit. So just be sure and remember that the indoor unit is going to be defaulted on a compressor call to high-speed airflow. And this is going to be important in a minute or two, as you'll see that we're going to energize S1 for a low speed command or a low airflow command. So that's important that we remember that. So on these products, on the HMH7, high speed or 100% airflow inside will be the default airflow point. C goes all the way through, as we commented earlier, common to common, all the way through 24 volt common. R is 24 volt hot. It does not go outside. That's an important concept we want to remember. The R terminal does not go outside. We don't need it outside for normal function. And G is going to be our fan call. That's pretty straightforward. Now on the JHVT air handler, you're going to notice there's going to be an S1 input. That's going to go to S1 outside. And what that is, that's going to be your airflow reduction command. So remember, team, on the HMH7, the default airflow inside, when it first comes on, is going to be 100% airflow. And then based on its point of modulation outside, the outdoor unit will make an intelligent decision when it hits about 60 to 65% modulation as it's screwing down its modulation or its capacity. It'll then command a lower airflow inside, 60, 65% airflow inside. And the reason we do that, we want to closely match that outdoor capacity with our indoor airflow so that we have good comfort and humidity control and so on. So remember, on the HMH7, the S1 command is a airflow reduction command. Any questions or comments on the basic block wiring diagram so far?
Not yet.
Okay, good, excellent. So as we take a look at it, so here we are, we're cruising along, and let's say we're at 100% capacity and we've got full airflow right now. Well, when the outdoor unit reaches a point of capacity to where it wants reduced airflow, what it's going to do is going to energize that S1 circuit, that S1 input from the outdoor unit, and it's going to tell the air handler, go to 65% airflow. So remember, on the HMH7, the S1 input to the indoor unit is going to be a command for reduced airflow. Good. Okay.
Is that for dehumidification?
It is. It's for dehumidification, but you also got to remember the outdoor unit will modulate between 35 and 100% capacity. And when it starts getting down into that 60% capacity or 65%, we reduce the airflow, to your good point. because if we were blowing 100% airflow, but we're at, say, 55 or 60% capacity, what it's going to do, your humidity control is going to go in the toilet, isn't it? If we're blowing 100% airflow, but we're only producing 60 or 65% capacity on the outdoor unit. And so as we start screwing the capacity down, we want to reduce the airflow to reduce that humidity in the house. Because you got to remember something too, the HMH7, you know, it's not going to be at 100% all the time. As a matter of fact, it's going to be cruising along somewhere between, you know, 65 and 80% capacity most of the time, you know, during the day, once the house starts cooling off and so on. So what this does, it allows us to have longer run times, which is a good thing for humidity control. Because remember, team, you can't dehumidify a house unless the unit's running. So we have extended run times being, you know, very, very efficient operation. We modulate back and we reduce that airflow to control the humidity and to provide that extra level of comfort. But that's exactly why we do that, is we reduce airflow to help handle that humidity. Good question, good comment. Okay. So the JHET air handler is our standard ECM motor air handler. There is going to be a relay in there. You guys can kind of see there's a little relay down there. And what this is that 001 relay kit. Now, one of the things I want to remind everybody that we recommend that you buy that HMH7 AK001 relay kit because it has some harnessing in there. It's got the little relay board. It also has a biflow filter dryer already included in that kit. And so that's always a good idea, just to buy that install kit, if you will. It's easy and it's convenient. However, we've had some contractors say, well, listen, can I just put my own biflow filter dryer on? And the answer is, of course you can. And can I take a peanut relay and do exactly what we're doing right here and just make up field wiring instead of, you know, bothering with the harness and all that kind of stuff that comes in the kit? And the answer is, of course you can. But we find that most contractors, they enjoy having that kit, that 001 kit, where you have the relay already in there. You've got a biflow filter dryer. You've got some convenient harnessing and stuff in the kit to make it kind of easy. But either way you want to do it, just a plain peanut relay, single pole, double throw relay with a 24-volt coil will work fine if you want to make up your own field kit. So anyway, so the JHET is going to have a relay in there that we're going to utilize for relay logic to reduce that airflow. We're going to show you how that hooks up here in a minute or two. So just like before, B from the thermostat is going to go outside to B terminal outside, and that's for reversing valve operation in the heating mode. So we have to make sure that we have a thermostat that has that BO selection on there, that we can select B for heating or O for cooling, you know, based on the product that you're putting on. So we're going to use B terminal for the heating mode of operation on the outdoor unit. Again, if you've got a two-stage heat strip, W2 will be your second stage auxiliary heat. W1 will be your first stage auxiliary heat, and that's going to go all the way through, just like we talked about before. Pretty straightforward. Y will be your compressor terminal from the thermostat that goes outside. And you're going to notice that if you do have on the JHET air handler, some tonnages of air handlers have a yellow wire equipped on the ECM motor. Go ahead and remove that yellow factory wire from the motor, because we're going to be selecting several speed taps on that ECM motor. And we want to make sure that we don't have any, you know, multiple commands on that motor that we don't want. So if there is a yellow factory wire, if it's so equipped on the ECM motor, go ahead and remove that factory wire, because we're going to be selecting our own speed taps for different applications. Our common is going to go all the way through, just like we had before, and we discussed why we want to do that. Our terminal is 24-volt hot. It does not go outside, just like before. And G is our fan call. Now, we typically are going to ask, or we're going to recommend, because it's the most typical that we see, G will go to the lowest fan speed tap on the ECM motor, like a speed tap number 1. So basically, if the homeowner goes over and selects continuous fan just for circulating air, it'll go ahead and enable the fan on the lowest speed tap. Now, you can select whatever speed tap you want, but typically we find that G is going to be our lowest speed tap on the ECM motor. From one side of the relay coil, B terminal, or one side of the relay coil, that's going to go up to S1. On the actual relay itself, the relay coil, one side of the coil will go to S1. The other side of the coil will go to common, which makes sense because that'll complete your 24-volt control circuit. So whenever we call for S1, we'll energize that relay. You'll notice that on the common switching terminal of the relay, we're going to go grab the yellow wire going outside to the compressor. So that's our power to the common terminal of the switching relay. Now on the motor itself, we're going to take the high-speed tap off the ECM motor and we're going to go to W1 auxiliary heat. So basically, anytime we get a W call, we're going to drive the fan. Now this is, again, typical. You can select whatever speed tap you want, but we typically drive the ECM motor to high-speed tap on an auxiliary heat call. That way we don't overheat the heat strips. And so this is the most typical wiring that we see. You know, from the ECM motor, we'll go up and we'll grab the high-speed tap for the auxiliary heat call. Then on the motor itself, we'll have the normally closed contact on the switching relay. The normally closed contact on the switching relay. We'll go over and we'll select a speed tap that's going to give us 100% cooling airflow. Now, this is important, guys, when you're setting these up, that you measure your airflow, and you want to set your airflow up for 400 CFM per ton. So if I've got a 2-ton unit sitting outside, I need 800 CFM. If I've got a 3-ton unit sitting outside, I need 1,200 CFM, and so on. So this normally closed contact on the relay, we're going to go over and we're going to select a speed tap on the motor that's going to give us 400 CFM per ton, or in other words, 100% cooling airflow. On the normally open contact, of the switching relay, we're going to select a speed tap on the motor that's going to give us about 60 to 65% airflow. So this could be, you know, maybe it's speed tap number 2 or maybe speed tap number 3, you know, just based on your duct work. When you commission the unit, you're going to measure your airflow, but we're looking for about 60 to 65% airflow. Now, by the way, on this normally open contact here, and you're selecting your 60 to 65% airflow on the ECM motor, it is unlike the variable speed motor where you can actually set your dip switches to give you the exact airflow you want. We want you to be close to 60% airflow. So let's do an example. Let's say your speed taps are such on your duct system that you have, you know, one speed tap gives you 55% airflow, and then maybe another speed tap gives you 70% airflow. Well, I would probably select the one for 55% airflow, because, you know, what's going to happen is if you have too much airflow, to our comment earlier, if you have too much airflow on that reduced speed tap, what's going to happen is you could have some humidity issues. So if I had a choice between 55 or 70% airflow on that normally open contact there, I'd probably go with the 55%, but we're asking you to give us a nominal average of about 60 to 65% on that speed tap. And if you have to select one, make sure it's closer to 60%, because that'll give you good humidity control. Does that make sense to everybody? And is there any questions or comments on the block wiring diagram? Everybody good?
Yeah. Yeah.
Okay. Couple things I want you guys to remember is that when I have an S1 input, remember, let me do that animation again. Watch it closely. When I have an S1 input, we're going to switch that relay and we're going to command reduced airflow. So one more time, there's our 100% airflow. When we give it an S1 input from the outdoor unit, that switches the relay and it gives us reduced airflow. In addition, we want to remember that any W1 call or auxiliary heat call, if that's present, it's going to drive the fan to 100% airflow. And even if we have an S1 input, it'll have no effect, because remember, on the ECM motor, it's going to look for whatever airflow's got the highest command. And if it has more than one speed command on that ECM motor, it'll always take the highest command that it's receiving. And then finally, please remember there will be a W1 input anytime we have a call for defrost operations. So we're just remember those little things there, that a W1 input, any W1 input, it's going to drive the fan to high speed, and we will have an auxiliary heat call during defrost. So that's important that we remember that. Okay, now Tony had commented yesterday when we were talking a little bit about this that you guys may occasionally sell like an 80% furnace. So I wanted to go ahead and throw a little dual fuel W circuit control in here for you. And we noticed that with in dual fuel applications with the furnace, the outlet unit's normal sequence of operation will be to bring the indoor unit on for about a minute, and this can cause some short cycling of the furnace. So what we're going to do is there's a little circuit in here that we're going to talk about, our dual fuel W circuit. And what we're going to ask you to do is to choose one of these little dry out heating thermostats of about 65 degrees.
Hey, Joel.
Go ahead.
Joel, so guys, do you do any dual fuel applications? Do you anticipate that? We don't want to cover something that
Yeah, that's a good point.
Yeah, straight AC with gas heat.
Just straight AC with gas heat.
Okay. All right. Well, let's go ahead and jump over that then. We won't bother with just let me fast forward a little bit here. We won't bother with that today then. But let's go ahead and talk a little bit about some airflow considerations. This goes along with any of our HMH7 modulating units. We want to make sure you consider airflow as a main consideration, because remember, on every install, the airflow on an HMH7, because it's modulating, it's going to be critical. And so we commented earlier, we want to make sure that you size your ductwork to provide 400 CFM per ton of total cooling capacity. So if I've got a 2-ton unit outside, I want to make sure my ductwork will support 400 CFM. And so it's important that you build your duct systems and commission your duct systems to provide 400 CFM per ton of capacity. In addition, when you start really digging into Manual D, this is right out of Manual D, we want to make sure that when you build those duct systems, you not only consider the CFM, 400 CFM per ton, but please consider also the recommended velocities that we see in Manual D. To give an example, on your main trunk, we ought to be designing our main trunk velocities to be somewhere around 700 feet per minute, not to exceed 900. And so, because what we're saying, if the air is moving too fast through the ductwork and going across the evaporator too quickly, it won't dehumidify like it's supposed to. So we want to make sure that we really watch our velocities as well. And again, this table's right out of Manual D. If you go to Manual D, Chapter 3, you'll find that there's going to be some good recommendations in there for your supply, as well as your return duct velocities. So please consider those as well. Your branch runs, I'm not going to go over and read every one to you, but your branch ducts ought to be about 600 feet a minute. On your takeoffs, registers and grills, about 500 feet a minute is recommended velocity. Diffusers about the same as recommended velocity. You'll notice on the returns about 400 feet a minute velocity. Now this is really, really important, especially if you've got like single returns in a hallway like you might have down in your area. This is really important. If you've got a filter grill, if you have a return grill with a filter in it, Manual D recommends that you size that filter grill so that the velocity across that filter does not exceed 300 feet a minute. So what this means, what this ends up being, you're going to probably have a little larger returns than you maybe normally would. But this is all a good thing, because again, on a HMH7, it's a modulating unit. So we really want to make sure we've got plenty of good return, and we want to keep those velocities across that filter. If you've got a filter grill on your return side, you want to make sure you don't exceed about 300 feet a minute velocity across that filter grill. So please consider these when you are installing these units and you're commissioning your ductwork. Build them for 400 CFM per ton total capacity of airflow, and then watch those velocities, because they can sneak up and get you in a way that'll cause erratic operation and possible icing the coil and stuff like that. So please watch those velocities as well. So with that, We're going to go ahead and bring the PowerPoint presentation to a conclusion, and then we're going to go ahead and open the floor up for any. Let me go ahead and get rid of this. Let's go ahead and open the floor up for any final questions or comments we might have this morning as I turn my camera back on and as we start wrapping up our training overview this morning. So let's go ahead and do that. If there's any final questions or comments, we can certainly do that.
Matt, you got any questions?
No, I think we're good.
We're in good
For now.
shape.
Yeah, you got- So
You
when's
might
your
just-
install? When's your install?
Thursday. You might get a call Thursday.
Yeah, no, I
Okay.
don't mean there's no calls allowed Thursday if you don't ask any questions now.
For the homeowner, we've done a lot of these.
Yeah, please call me anytime. Absolutely.
So they are putting in the JHET with the relay kit. So they're not
Okay.
doing the variable speed on Thursday.
Adam.
Yeah.
That kit that I ordered, the kit that he was talking about with the filter dryer and everything, is that part of that, or is that just the relay that I ordered?
You just have the relay kit.
Okay, so we just need to make sure we put a filter dryer.
Okay, so just real quick,
Yeah.
Adam, did you sell them the HMH7 AK001 kit?
That's correct.
Okay, inside that box,
Yes.
that kit box, you're going to have some harnessing.
Okay.
You'll have some convenient harnessing. You'll have a little biflow filter dryer in there along with the relay kit, or with the
Oh,
relay.
the dryer is in that one?
It is. It comes with the kit. That's right. So good question.
The only thing I just wanted to reiterate, and I'm sure you addressed it during the training, is when you guys install the HMH7 unit
Yes.
and you use the X13 air handler, you always have to have that relay kit.
That's an excellent question. That is absolutely correct. So on the JHET air handler with the standard ECM motor, and as you referenced, the older designation was X13, you have to have that relay kit for that airflow switching and that relay logic. That is correct. Good question. Good.
There's a separate if you do end up, Matt, if you guys do end up ever having to do the variable speed air handler, I have a bunch of like cheat sheets for the wiring, like how to set everything up specifically for that air handler. I'll get those over to you guys, but I just wanted to make sure that you guys knew that when you do thank you for correcting me, the ECM, that's an old reflex on the X13, that you have to always have that kit. So if you guys order the ECM motor unit and you don't have that kit, you're going to have an issue with your install.
Okay.
Absolutely. And there's a little side note to kind of tag onto that. When you order or when you install the JHVT, the variable speed air handler, where you don't have to have that kit, you want to make sure and have available to you a biflow filter dryer, because if you're not using the kit, you're going to have to field install or field provide a biflow filter dryer. So with the variable speed air handler, you don't need the kit, but you will need to put a biflow filter dryer in there. Good. Any other good questions or comments before we secure for the day?
What time are we meeting for lunch, Adam?
Okay, sounds
good question.
That is a good question, Adam. What time's lunch?
Yeah, right.
I'm still